Good day student, today we study the voltage divider biasing amplifier circuit. The voltage VCC, resistor R1 and resistor R2 will act as voltage divider circuit. This circuit is very stable biasing circuit because the current ICQ and voltage VCEQ are almost independent of the variation in beta. That means if the temperature is increased, the Q point, that is current ICQ and voltage VCEQ, are almost the same. First, the voltage VCC, resistor R1, resistor R2, resistor RC, and resistor RE will determine the Q point of transistor BJT. The capacitor C1 is used to block the DC current go through to the input voltage VI. The capacitor C2 is used to block the DC current to the output voltage VO. To do the DC analysis, the first step is capacitor C1 and capacitor C2 is open circuit. And then the second step, we simplify the voltage divider circuit using the Thevenin theorem. And then we analyze two loops, that is BE loop, to find the current IB and current IC, and then we use the CE loop to find the voltage VCEQ of the transistor BJT. Firstly, to do the DC analysis, the capacitor C1 and C2 are replaced with open circuit. Then this one is the DC equivalent circuit. The second step, we simplify the voltage divider circuit, that is VCC, R1 and R2, by opening the point of base of transistor BJT, and then we find the voltage Thevenin, which refer to the base, which is equal to R2 over R1 plus R2 times VCC, and then we find the resistance Thevenin that also refer to the base of transistor BJT, where the resistor Thevenin is equal to R1 parallel R2 equal R1 times R2 divided by R1 plus R2. The third step, we analyze the BE loop and CE loop using Kirchhoff voltage law. BE loop is used to find current IB and current IC. VCE loop is used to find the voltage VCE. For BE loop, VTH equal IB RTH plus VBE plus IE RE. For CE loop, VCC equal to IC RC plus VCE plus IE RE. BE loop is used to find the current IB and current IC, where voltage VBE is given in the exam, which is 0.7 volt. From BE loop, VTH equal to IB RTH plus VBE plus IE RE, but IE is equal to 1 plus beta IB. So you can get VTH equal to IB RTH plus 1 plus beta RE plus VBE. If you simplify the equation, so you can get IB equal to VTH minus VBE divided by RTH plus 1 plus beta RE. If the voltage VBE, voltage VTH, resistance RTH, beta, and resistor RE is known, so you can get the current IB. After that, you use the general formula, that is IC equal to beta IB, to find the current ICQ. The CE loop is used to determine the voltage VCE, where VCE equal to ICRC plus VCE plus IERE. Then you get VCE Q equal to VCC minus ICRC plus RE, where IE is almost same as IC. Example 4.9. Determine the Q point of transistor BJT, that is IBQ, ICQ, and VCEQ. Given beta equal to HFE equal to 140 and VBE equal to 0.7 volt. Firstly, you open circuit the capacitor C1, capacitor C2, and then capacitor CE. After that, you get the equivalent circuit of voltage divider, that is VCC, R1 and R2, by opening the point of base of transistor BJT. After that, you get the voltage Thevenin, that is R2 divided by R2 plus R1 times VCC. So after you put the value, you can get Thevenin voltage equal to 2 volt. Then you get Thevenin resistance, that is R1 parallel to R2 equal to R1 times R2 divided by R1 plus R2. So after you put the value, so you can get Thevenin resistance is equal to 3.55 kilo ohm. From BE loop, you can get VTH equal IBRTH plus VBE plus IERE. Then you replace the current IE equal to 1 plus beta IB. Then you get IB equal to VTH minus VBE divided by RTH plus 1 plus beta RE. So after you put the value, you can get IB equal to 6.05 microampere. Then you use the general formula IC equal to beta IB, so you can get IC equal to 0.85 milliampere. From CE loop, you can get VCC equal ICRC plus VCE plus IERE. So you can get VCE equal VCC minus IC plus RC plus RE, where IE equal to IC. Then you get VCE equal to 12.22 volt. So the Q point is IBQ equal to 6.05 microampere, ICQ equal to 0.85 milliampere, and VCEQ equal to 12.22 volt. For approximate analysis, I will not discuss because it is not involved in your test and final exam. This is also not involved in your test and final exam. This is also. Example 4.11. Determine the Q point of transistor BJT, that is IBQ, ICQ, and VCEQ. Given beta equal to HFE equal to 80 and VBE equal to 0.7 volt. Then sketch and label the DC load line of the circuit. Firstly, determine the Thevenin voltage and Thevenin resistance using the voltage divider circuit, that is VCC, R1 and R2, by opening the base point of transistor BJT. After that, you find the voltage Thevenin, that is R2 divided by R2 plus R1 times VCC. Then after you put the value, you can get with Thevenin voltage equal to 2.05 volt. After that, you find Thevenin resistance, that is R1 parallel R2 equal to R1 times R2 divided by R1 plus R2. Then after you put the value, you can get Thevenin resistance equal 7.94 kilo ohm. Using the BE loop, you can get VTH equal IBRTH plus VBE plus IERE. Then you convert IE equal to 1 plus beta IB. So after that, you can get IB equal to VTH minus VBE divided by RTH plus 1 plus beta RE. After you put the value, you can get IB equal to 21.42 microampere. Then you use the general formula IC equal to beta IB. So after you put the value, you can get IC equal to 1.71 milliampere. Using the CE loop, you can get VCC equal to ICRC plus VCE plus IERE. Then you can get VCE equal to VCC minus ICRC plus RE, where IE equal to IC. Then you can get the voltage VCE equal to 8.17 after you put the value. So that the Q point is IBQ equal 21.42 microampere, ICQ equal 1.71 milliampere, and VCEQ equal to 8.17 volt. DC load line is determined using CE loop, where you can find that VCC equal to ICRC plus VCE plus IERE. Then you can get VCE equal to VCC minus ICRC plus RE, where IE is equal to IC. At cut-off region, so IC is equal to 0 milliampere. So you can get VCE cut-off equal to VCC equal to 16 volt. Then at saturation region, VCE equal to 0 volt. Then you can get IC saturated equal to VCC divided by RC plus RE. Then after you put the value, you can get 3.49 milliampere. Then after you plot the graph, and then you know what is the value of IB, so you can get the Q point, that is VCEQ equal to 8.17 volt and ICQ equal to 1.71 milliampere. For the DC load line analysis, VCE cut-off value is same as the fixed bias circuit analysis, and then whereas the IC saturated value only same as the fixed bias circuit.